For our first example, we are told that a resultant force of 3I plus 8J newtons acts upon a particle of mass 0.5 kilograms. The first part of this question, we are asked to find the acceleration of the particle of the form pi plus qj meters per second squared. So we want to find the acceleration in terms of the unit vectors I and j. We're going to be using the fact that F equals ma, where F and A are vectors, because force has a magnitude and a direction when we're looking at motion in 2 dimensions, as does acceleration. So for part A, we're using F equals ma. Our resultant force, F, is 3I plus 8J, and that's equal to the mass, which is 0.5, multiplied by our acceleration vector, which we are trying to calculate, A. So we've just got now a linear equation that we need to solve, which is a vector equation. So we're going to divide both sides by 0.5, and we get 6I plus 16J equals A. I'm then going to just write my answer in the form that the question's asked me to. So A equals 6I plus 16J meters per second squared. For part B, we're asked to find the magnitude and the bearing of the acceleration of the particle. Now, in order to do this, what will help is if we draw a diagram of this these unit vectors here for the acceleration. So 6I plus 16J means we're going 6I across. 16J is our upwards direction, and our acceleration is the vector 6I plus 16J, so it's from this point to that point. So we want to find out, first of all, the magnitude and then the angle here, so we can then calculate the bearing. So we're going to find the magnitude of the acceleration first. So we're going to do the square root of 6 squared plus 16 squared, which is equal to 2 root 73, which to 3 significant figures is 17.1 meters per second squared. We're then going to find the angle here so that we can find the bearing of the acceleration. So we're going to use tan theta equals the opposite, which is 16, over the adjacent, which is 6, because this is a right angle triangle here. So using our trig ratios, tan theta is the opposite over adjacent. So theta is equal to the inverse, tan inverse of 16 over 6, which is equal to 69.4 degrees to 3 significant figures. So the bearing of the acceleration, the bearing is, if we look at our line going north here, the bearing is going to be that angle there. I'm going to call that alpha. So the bearing is 90 degrees, subtract 69.4, which is 20.6. So just remember, for bearings we always write down what the value is in the hundreds column as well. So this is just the notation for a bearing. So we would say the bearing of acceleration is 0 to 0.6 degrees. for our second example, we've got 3 different forces acting on a particle with a mass of 3 kilograms, and we want to find the acceleration of the particle. So all of these forces are acting on a particle. We need to find the resultant force of the that's acting on the particle, and then we can use F equals ma, because we've got the resultant force, we've got the mass, so we can then set up an equation and solve it in terms of A. So the resultant force, that is equal to the sum of all of those forces. So the reason why it's equal to the sum of all of these forces is that all 3 of these are acting on the particle, which implies that they're acting in the same direction. So we've got no forces in the other direction, so we don't need to subtract any of these. So we've got 2i plus 4j plus negative 5i plus 4j plus 6i subtract 5j. So all we do here is we add all of the I coefficients and add all of the j coefficients. So for the I coefficients, we've got 2, subtract 5, which is negative 3, then add 6, positive 3. So we've got 3i. For the j components, we've got 4, add 4, which is 8, subtract 5, which is 3. So 3i plus 3j. So this is what F is equal to. So F, our resultant force, is 3i plus 3j. We're then going to use F equals ma. So 3i plus 3j is equal to the mass times acceleration. Mass, we've got that's 3 kilograms. So that's equal to 3 lots of A. And we can see that A, if we divide both sides by 3, is equal to I plus j. Remember that A is in metres per second squared. For this last example, we've got a similar question, but our forces are in column notation. So we are going to again be using F equals ma. We are given all 3 forces that are acting on a particle with a mass of 60 kilograms, and we're told what the acceleration is, but one of our forces, F2, has some unknowns, P and Q, in there. So we're going to be setting up some equations to solve in terms of P and Q. So first of all, we're going to find that resultant force, which is F. F equals F1 plus F2 plus F3. Now the way that this is done, we are going to add all of our column vectors together by just adding the top components and then adding the bottom ones. So minus 75, 100. So when we add these together, for the top row, we're doing 80 plus 10p subtract 75. So that's 5 plus 10p. 50 plus 20q plus 100. So that's 150 plus 20q. Now F is equal to ma. So 5 plus 10p, 150 plus 20q, is equal to the mass, which is 60, times by the acceleration, which is 0.8 and minus 1.5. We're going to multiply this column vector by this scalar of 60. 60 times 0.8, that's 48. 60 times negative 1.5, that's negative 90. So we've got that this column vector here is equal to this column vector here. So we can set up an equation in terms of P using the top row and set up an equation in terms of Q using the bottom row. So to find out the value of P, we've got 5 plus 10p is equal to 48, which means that 10p is equal to 43, and so P is equal to 4.3. For the bottom row, we've got 150 plus 20q is equal to negative 90, which means that 20q is equal to negative 240, which means that q is equal to negative 12.